You'll notice by our review that we kind of worked backwards as the year goes. So here at Station 8, what you're talking about is functions, which is pretty much what we started the year with. On these, I want to remind you that you need to use critical thinking skills when you're looking at multiple choice problems. Particularly if you're asked to take a table and show me a graph, or given a graph and asked to be a table, or even an equation. If you cross out an answer, it should be because you can prove that it's wrong. Otherwise, you need to consider everything until you see a specific reason why one is right. This is not a good place for guessing. For functions, one thing you need to understand is independent and dependent variables. So you'll remember independent is the x and dependent is the y. In a verbal situation, this is the one we can control, or the cause, and this is the result. You'll also want to remember some things about domain and range. Domain is all the x values that are possible, and range is all the y values that are possible. We're going to practice getting domain and range here in just a moment. You may remember that there are two ways that I can write domain and range. If it's a discrete function, remember discrete means specific points like a scatter plot, you're going to write them in a list like this. And then if they are continuous, meaning a connected line in this case, remember you're going to write them like this, where x is in the middle for domain or y is in the middle for range. That's really important that you remember the difference in these two so you don't get caught off guard. One last thing on that continuous. If it looks like this, that less than sign, it's because the circle on the end is open. It's kind of like the line thing when we talk about dotted or solid. No line underneath means open circle. If I have less than or equal to, that should be a solid circle endpoint, just like a solid line if I'm looking at my linear inequalities. And then one last thing, we want to remember that a relation is a function if the x's do not repeat. So you're going to be asked a couple times, is the relation a function? And yes, it is if the x's do not repeat. Graphically, this means that the line passes the vertical line test. Hopefully you remember that that means if I look at the function and I draw a vertical line, I can draw lots of vertical lines, they can only cross once. If it crosses more than once, it's not a function. Let's look at a few specific examples. Such as, you have counted the number of people on the subway platform each morning between 9 and 10 a.m. You have charted your findings below. Graph the results and answer the questions that follow. Hopefully your brain is trained that when you see a function like this as a table, you know you could put that in your stat edit menu and get an equation. Unfortunately, that's not what I'm asking you here. I'm asking you some different questions, such as what is the independent variable? So, variable means something that changes. That means I could not put March or 128. That's not a variable. Something that's changing and is independent, my x values, is the month. And my dependent variable, or the y values, are the number of people. You might say, what number of people? The number of people on the platform. If you can identify independent and dependent, you'll be better off when you go to make your graph. I'm working with limited space, so I know my handwriting is pitiful. This would be the number of people, and on the x-axis, I would say the month. Now you may say, Miss Lawler, I don't know how to put January in a month. That seems kind of weird. Well, January is the first month, February is the second, third, fourth, fifth, sixth, and you'll notice that my table stops at June, so I really can't graph anything past that. What if I was given a graph where they didn't give me the values? Well, I would just kind of have to estimate, and that's something that you can do because I go in order, increasing from least to greatest. Then I look at the number of people, and I can see in January there were as few as 20, and in May there was as many as 128. So I need to think carefully about what kind of values I want to go by here. Maybe I want to go by 5s, 10s, 20s. I'm not sure. I'm going to go by 10s, and I'm just going to mark the first few because I wrote right here so I don't have the space. And then I'm going to graph. 1 goes with 20, 2 goes all the way up to 100, so 30, 40, 50, 60, 70, 80, 90, 100. 105 would just be about halfway. 97 would go a little under. Okay, we said that was 100, so 110, 120. Oh, did I get off by one? Nope, 128. Okay, a little higher. And then in June, we went back down to 100. Looks like I did get off a little bit here. I graphed 2 right here. In fact, this is a good teachable moment because if I'm looking at these, I can tell that this is not a function the way I drew it. Right? I've got 2. That didn't pass the vertical line test. So in your mind, you just need to shift these over 1. And that's the kind of stuff you're going to want to check on a multiple choice problem. All right, now I want to talk domain and range. So for domain, this is a discrete. You can see I did not connect these. There isn't a person halfway between January and February, so that wouldn't make any sense. When I talk domain, I want to say all the x values. I could either list the months of the year, or I could list the numbers. So I have 1, 2, 3, 4, 5, and 6. And it may be a good idea to label up here in your table as well so you don't miss anything. Then when I think about range, I want to go from least to greatest. And I see 20, 97, 100, which I listed twice up in my table, but I will not in my range. And 105, and again, space is an issue for me here today, isn't it? And 128, so I got the 20, the 97, the 100s, 105, and 128. I got all my values. Now I know this is my domain and my range. And the last question I'm asked is this a function or not? Now, I already talked to you about how I made a little mistake over here on my graph. So the way I've drawn it, it's not a function. But going back to the original question, I want to know, is it a function or not? Remember, we said function is anywhere where the x's do not repeat. Did I do January twice? No. February, March? No. All the months are specific. The x's do not repeat. That means this is a function. You may say, but Miss Lawler, the y's repeat, so is that okay? Yes, the y's can repeat. It's the x's that we're looking out for in a function. Okay, one last thing that I want to show you here is what about domain and range if I'm talking continuous? Well, we did all kinds of things to try to help you see this. One of the things we did was we used a highlighter or your hands to try to mark this off. But since then, I've kind of been thinking that maybe another way to help you would be if you said what this point is. So -5, -2, and this other endpoint, do the same thing. It's 4, 3, and I'm just reading the ordered pair, 4, 3, -5, 2. When I'm talking domain, I want to know the x values from least to greatest. So my smallest x value is over here, -5. My largest x value is over here, 4. And then I want to check my circles. This one is open, so I'm going to leave that line alone. And this one is closed, so that inequality needs the line under it. And now I can see that that's my domain. If this was in multiple choice format, guys, be sure that when you're talking about x's, you use the variable x for domain, and you use the x of the ordered pair. If you don't, that's going to be a mistake. Now let's look at range. Range is y values. These symbols are always the same. And I wanted to go from least. My smallest y value is -2. And my largest y value is 3. All my other y values go somewhere in between there. Again, I want to look at my circles. The one with -2 is an open circle. The one with 3 is a closed circle. So I'm going to do the line underneath, and that's it. I'm done with that problem. Again, very straightforward if you'll follow the steps. Now, there's a lot to remember, so we'll just have to kind of keep on top of that. The very last thing on your review, and one of the things on your test, is about function notation. So if you're given f of x equals 3 times x plus 9 minus 1, what is the function at -2 is asking you, if y equals all this stuff, what is the y value when x equals -2? The best way to do this is to go use your calculator. So go to y equals, clear out anything that may already be there, and type in this function exactly as you see it. Again, you'll want to do that carefully. If you type in the wrong function, you're going to get the wrong thing. So I double check 3 times x plus 9 in parentheses minus 1. Be sure it's a minus and not a negative. That'll make a big difference. And then you want to go look where the x value is -2. So I'm going to go look at my table by hitting second graph. And I'm waiting for it to load here. As it loads, I see that I only have positive x values, so I'm going to want to scroll backwards. And where x is equal to -2, y is equal to 20. So what I'm going to do is I'm going to go to my griddable. I'm going to put 20 over here all the way to the right side. I'm going to shade in my 2 and my 0. I'm going to leave everything else blank because it's a positive answer, so I don't need to do anything with that. I don't want to make any room for errors. All right, you're all done.